All right, here we go. And so today I want to continue with arrays. The assignment is a long list of problems to solve. I'm wondering how far you've gotten through that list. There's small problems. There's a lot of small problems. Yeah. Is there? What I'll do is I'll look at I can demonstrate the solution for some of them, and then you can see me solve it. Hopefully, after you've already perhaps struggled with them, because then it'll be more meaningful to you if I show you how I do it. But if you haven't tried the problems yet, then you're not going to get as much out of me showing you the solution. So a lot of what you need to do in this class is just to exercise your problem-solving skills with these problems. It's memorizing solutions that I present to you will help a little bit. But ultimately, to do well, you need to solve problems without having seen the solution in advance. All right, so let's look at that. There's one that I know I want to get to, so let's do that one first. This one here is all zeros. And because here we see a two-dimensional array. Now let's solve this problem here. So I'm asking you to implement this function that's called isAllZeros. It returns true or false. The return type is bool. And it takes as a single argument an array A here. That's arbitrary, that name. And the array has two dimensions. It's got 50 rows and 100 columns. The function returns true if every position in the array contains a 0. Otherwise, it returns false. All right, let's take a look at that. So here's the beginning of our test code. Let's see if that compiles. It does not compile. This is not a good stub because it doesn't return true or false. Let's make it a good stub by returning true there. All tests passed. There we go. So now what we need to do is create an array, two-dimensional array, and we'll need to do two tests. One where we have an array that has some non-zero value in it, and another array which has all zeros in it, just to make sure our function works correctly. So let's follow that pattern of writing the test cases first, and then we'll implement the function. So let's think about that. So it's an integer array. Now we won't be able to use this notation because it's too many zeros to list. Plus, I don't know if it works with a two-dimensional array as well. It probably does. So let's declare this array to be 50 by 100. And it's uninitialized, so it has random values in it. So let's iterate through through all the valid indices for this array, two-dimensional array, and set all the values to 0. So let me use, instead of I'll use R for rows.
So we've got 50 rows and 100 columns. So what we've done is written this nested loop to iterate through all the index pairs for this two-dimensional array. So they're going to hit every cell in the array. So let's say for each cell that we hit, let's assign a 0. And let's call the function is all zeros, pass in A. I'll just go equal equal true for readability, although that's not needed. Now this will, of course, passes because the stub is returning true.
So we're not checking if all the numbers are 0 yet?
No, we're not checking anything, just returning true. That's what I call it. We're writing the test code first. So test first strategy. And then let's go ahead and change a random cell to something that's not 0. I'll put to -1 to try to confuse the program a little bit. We use a negative number. And then when we run this assertion, it's not all zeros anymore. So it should now be false. Now this test will fail because the stub always returns true. So we've got our test code written. Now let's go ahead and implement the function. Well, we'll need the same kind of loop here. Just going to copy that up here. Iterate through the rows, iterate through the columns. And what do we look for? What do we look for here? If we've got to check something, right? What do we check?
Size?
I want to check, see, ARC is some cell in this two-dimensional array. And R and C is iterating through all the values. R is going from 0 to 50, C is going from 0 to 49, C is going from 0 to 99. So for each of those pairs of indices, you want to make sure that there's a 0 in every slot, right? And we return true if everything is a 0. So that means we return false if we find one bad one. So we're going to test for a bad one. If ARC is greater than 0, return false. It's not all zeros.
Couldn't we also do the exclamation point equals 0?
Yeah, that's a good idea. Could we do this?
Would it be 2 of them or no?
Well, we don't need both of them, right?
No.
Well, let's suppose we go with the first one.
I mean 2 equal signs. Do we need 2 equal signs?
Oh, 2 equal signs. And that's a good question. This is then we return true, right? Or false?
True, but okay.
Well, we're going to return true when we hit our first 0. What if the second slot has got a non-zero? We're returning true by just looking at the first cell position. Yeah, this is the theme of this course, this problem here. So this comes up with checking for prime numbers. This came up last time for something else. I can't remember what it was. Oh, the lucky is the, is lucky function. See, we want every cell to be 0. So if we look at one cell, we can't say true, they're all 0, right? We have to look at every cell. So this one's not going to work. That one's not going to work. We have to look at every cell. Looking at every cell means we finished the for loop. So down here, look, at this point in the code, the for statement has completed. So we didn't find a non-zero. Now we can return true. If we return true inside the loop, we're going to miss out. I guess we can look at that. Why don't we just look at that? Let's see it. Let's see that the test case fails. Let's put it in like that. See, we're not returning false anywhere, so that would be maybe else return false. See, this code here, look, this will always return immediately on the first iteration of the loop. We don't do any looping. The first time we enter the loop, an if-else statement, you're going to either execute the true part or the false part. So you're not going to do any looping. You'll enter the loop once and then you'll return. Should we bother to, well, let's go ahead and check that that fails. Insertion failed. Is all zeros false? Line 30. Should be this one, right?
Unless it returned true up there.
Oh, because we're returning true. That's right. We're returning true. And so this is still works, doesn't it? Let's take that one out. Let's just do this one. Is that going to work?
That one's the one that failed.
That'll fail. That's right.
Equals false.
Good. That one fails. So this approach won't work. And this pattern comes up over and over again. This is now at least the third time we've seen this. All right, what about this? Is that going to work? It says all test passed.
So we don't need the logical equal sign?
Wait a minute. Oh, that's the one. I didn't want to test that one. Sorry. I ruined my joke here. Not my joke, but the punchline. I missed the punchline. It's not really a joke, but it's a point I wanted to make. This is the one I wanted to test first. Sorry. How about this one?
Testing a negative number?
Yeah, see, that's the reason I put a negative number in there. Just because I had this sudden thought that, oh, what if the programmer used this condition rather than not equal to? Then it wouldn't look at a negative number. It would treat a negative number as if it were a 0. See, that's why, you see that? You want to try to crash the thing. You're not, as a tester, you don't want to be like careful. It's like, I don't want to crash here. I don't want to try anything that's going to show a mistake. So you want to be, you want to try to attack it. So let's see. There's the failure. So this is no good. So we need not equal to. So this, we've already seen that runs. There we go. Okay, that's that one. What should we do next?
First one.
Huh?
First one.
Number 1. Find the maximum. All right, let's do this one. Here's a function. The name is my maximum. my maximum takes an array of integers and the number of elements in the array, because it's not a vector. A vector has a size function, so you know the size of the vector, but an array doesn't have attached to it, a size function or size information. That information has to be maintained separately from the variable a itself. So we need to pass in the size of a as a separate argument to the function. We didn't have to do that with the problem we just solved, because in the function declaration, we say there exactly how large the array is, the dimensions of the array. So that's hard-coded in there. But here, for one, we want a variable size array. In that case, we need to pass the number of elements in the array too. And what the function does, my maximum, it looks through A, one element after another, and it keeps track of the largest value that it's seen. And at the end of that process, it gets to the end and it says, well, the largest value that I've seen is 700. I'm going to return 700. I'm going to return the largest value I've seen in the array. That's my maximum value. You have to write test code for this. All right, let's do this one. Yep.
How many numbers are going to be included in the array?
Well, that's up to us. See, so I am getting sloppy. See, the array A is a variable size, so we have to design the function to handle different sizes. And let's go ahead and create an array here. Three, 10, 2. There's an array right there. We call my maximum with A. We have to give the size, which is 3, so we have to do that manually. And that should return, well, not true or false, right? What does it return? 10. That's the largest value, that's right. There's one test right there. One test. Of course, our stub returns 0. So that should fail.
But up at the top, oh, okay, you're returning a number. You're not returning true or false.
Exactly. We're returning the maximum value in A.
Okay.
So what's the algorithm? Basically it's how you think. What happened if you had a list of 500 numbers? If you have a list of 3 numbers, you're just going to say, well, it's a 10. And you don't even know what you're doing, actually, right? You just see it as a 10. But what if you had 500 numbers? What are you going to do to find the biggest number? You're going to have to scan it, starting on the left, or you can start on the right. I wouldn't scan it randomly, but you could try that as well, but you might get a wrong value. Start scanning it, and each time you make a mental note. Oh, I see a 7. Okay, and I keep going. 3, 5, minus 7, 11. Oh, I got a new bigger number. So 11. So you make a mental note of the largest number you've seen so far, and you scan all the way to the end of the list. And when you're at the end of the list, that mental note of the largest number you've seen so far, that's your answer. That's the largest number of the entire array, because you've now looked at every position in the array. So each time we get to a new value, AI, we're going to say, is AI bigger than, the biggest? The biggest seen so far. If AI is bigger than the biggest seen so far, then the biggest seen so far will now be set to AI. Right? So we've seen a new biggest. We see a new biggest. And then at the end, we just return biggest seen so far. And we'll need to declare biggest seen so far. I better initialize it. What do we initialize it to?
A.1 or A1?
What happens if we just initialize it to 0? Let's start with 0, okay? I know you guys know the answer there, but I want to. A lot of people think to do this. We have to initialize it to something, right? So this is a mistake, right? 0 doesn't work because if the list has all negative numbers, we'll falsely conclude that 0 is the largest value in the array. Oh, we better have a test case for that. So this is, see, that's the thing about these test cases. As soon as you think of a special situation, you want to write your automated test to include that. So here, the maximum is what? -2, right? And just to be extra careful here, well, that's an unlucky number. I'll just do that.
So the computer doesn't see the negative numbers as 0?
The computer does not see a negative number as a 0. It'll think, well, here, this is what we call the function my maximum. It should return -2. That's the biggest negative number.
But in the my maximum up there, it says initial A. Will it work just fine with the...
So it'll fail, and I'm showing it. So this initializing biggest seen so far to 0 is a mistake. It's a logic error. Because in this case, array B, all values are less than 0. And therefore the biggest value is less than 0. But we're initializing our variable up here, biggest seen so far, to be 0. And I'm leaving it like this because I'm writing the test code first. I'm carrying out what many developers consider current best practice, which is write your test first. Think of all the different situations, all the boundary cases and the oddball situations that for which your program unwritten program might fail on. And as we were typing this out here, we thought about this problem of initializing this variable. We thought, well, and it just popped into my head, well, what happens if, we put a 0 in there, but the array has all negative values. So instead of fixing the problem here, I didn't fix the problem here, because that's not the test first strategy. The test first strategy is, oh, this is a possible error. Let's write a test case that reveals that error for us. We'll leave the error in there and test that the test case properly reports that fault. So this assertion should fail right here. -2, there it is. My maximum is not -2. Does everybody see the solution? Does everyone understand? Is everyone following? Probably, I'm sure. I don't know if half of you know what to put there. How many people? No one's going to raise their hand, right? If I ask how many people don't know this, because I know it's hard to understand this stuff, and there's no way. I mean, if you're born smart about this, then you're going to get it just sitting in my class here. But I think that's a rare case. You need to work with this stuff. You need to work with it. So what we'll do there is initialize it to some known value in the array. So either we're going to stick with a 0, or else we'll find a new biggest value. That works. That works for that test case. Perhaps another test case that I just thought of, which maybe it's not that great of a test case, but just to be extra paranoid, let's put the biggest value in the first slot. Because that sort of is a special case. What about a test case where the largest value is negative and appears in the first position, which is what we're using, in our initialization step here? That's a way of sort of examining, developing more test cases that try to push the envelope. You had a question there?
Shouldn't that be a C and not a 3 on the third test case?
Not a 3. Thank you. Thank you. Saved us from debugging that. I was going to leave that one out, but let's put it in there. What did I do wrong? Int. Did I save that? What is it saying there? Unknown type name, C out. What happened? Why is that suddenly unknown type name, C out?
I've got that one too.
You got that?
I've got that when I was trying to, on the last exercise, it just randomly starts saying it doesn't understand C out.
What the heck?
Why not?
And that's a way, let's tell it it's in the standard namespace. See, I think C out is defined in here. That is odd. Wait a minute, I can't read that. Unknown type name, C out.
And there's an extra bracket. Oh, maybe it's not included in the... Do we have an extra brace?
Oh.
Oh, because the main function isn't closed.
Oh, what the heck? Ay, ay, ay. I just wasn't looking all the way down there. There you go. Okay, all right. What a weird one. It's full of surprises. We're just debugging a program with, 15 lines of code in there? Imagine a program like Windows, which is 10 million lines of code. Imagine debugging 10 million lines of code. No one person can read 10 million lines of code. You can't even read the code, let alone reason over its logic. How do you reason over the logic of 10 million lines of code? That's a huge software engineering problem. So I think we got this one. What's next? Number what? Who's stuck on? You got to be stuck on something, right? Unless you're waiting till the deadline. You're going to do this Friday morning. Let me guess. while you're in another class. Okay. Which one do you want to do? Nobody wants to see anything?
Yeah.
You guys aren't, you're not working on this.
Yeah.
I got stuck on the first one and
Yeah.
stopped.
Me too.
Oh, you got stuck on the first one.
Yeah.
Oh.
I just don't know where to start with pretty much anything.
All right, so that's the problem. I didn't give enough. Yeah.
Oh, so I got stuck on several of them, but I got stuck on the third one as well because I didn't understand how to append a vector onto a vector.
Let's do this one here. The problem with this one is that it's just hard to understand what I'm asking, right? All right, let's see. Implement a function called append vector. And this function takes a vector v, a vector of int v, and a vector of int w. So there's two arguments. There's the separating character between the two arguments. The first argument is a vector of int reference v. And the second argument is a constant vector of int reference w. Oh, look, this one is const, but this one is not const. How come v is not const? Yeah, we're going to change v, but we're not going to change w. What we're going to do is we're going to take the values that are in w and add them onto the back of v. That's what I mean by append. Attach onto the back of something. So for instance, if v were to be 425 and w were to be 11.3, then when you call the function, v will become 425, 11.3. So it's appending 11.3, the values from w. And here's the hint. We need to use pushback. We need to use pushback on v. I didn't ask for test code. We need the vector header. Oops. I didn't ask for test code, did I? This one is test code. I'll need to change the assignment and ask for test code. So let me do that later. But let's write the test code here. So let's create a vector v. I'll just copy that declaration there. And then let's push back onto v. And let's use the test right here in the problem statement. So 3, 6, 7, and no, that's not it. 4, 2, and 5. So 4, 2, and 5. And this is W. And this will be 11 and 3.
And in that bottom section that you just wrote in, you don't have to put const anywhere?
Here?
Yeah, you don't have to put
No,
const.
remember these have different scope. So that V and that W are different from this V and this W. We didn't have to call it V and W. I could have called it, you know, A and B. They have different scope. I just called it V and W because that's where I'm going to pass it into this vector, and V and W, the parameters V and W will be set to V and W from main. I just did it for readability. And perhaps at this level, you know, it's confusing for people that are still fuzzy about the idea of scope. Let's do it this way first, and then we'll do it the other way and see it. It's the same thing. So how do we write the test code for this? Well, a dot size. What size should a be when after we? Oh, let me call the function. So we call the function append vector, passing in the references A and B.
Have we made these values go to A's yet?
Yeah, that's what append vector does.
Okay.
So at this point, yeah, that's good because look, before we call append vector, watch this. Before we call append vector, what's the size of A?
3.
And after we call append vector, what's the size of A?
5.
And we got a test case right there. Let's spread that out a little bit. That's one thing we can test. And then we can test the values themselves. A of 0 should be 4. And A of 1 should be 2. A of 3 should be 5. Sorry, A of 2 is 5. A of 3 is 11. And A of 4 is 3. So we start at 0, right? 0, 1, 2, 3, 4. That's 5 things. The size is 5. So look at our function. That's a stub. Which assertion is going to fail? The first one? That one?
None.
No. The second one?
Yeah,
Yeah.
because the append vector is so stuck.
Yeah, we didn't change the vector, so it still has size 3. So let's see that assertion fails on this statement, a dot size equals 5. These are not, I copied those, you know, it's always dangerous to copy. Those are not references. Sorry. So that compiled. Assertion failed. A dot size equals 5. That's the one that we're in control here. You know, we know where it's going to fail. We think about it first. We identify, then we run it and see our predicted behavior. And then that gives us that feeling of confidence that we're in control. How do we do this? We're going to have a loop. And in the loop, we're going to call pushback. Pushback attaches something onto the back of a vector. Let's suppose we push back 0, huh? Yeah, what goes here?
W?
What's that?
W?
Well, W is a vector, and pushback takes, in this case, an integer.
So W bracket 0.
The first value from W?
W bracket and then a counter integer, maybe?
Yeah, that's right.
In a for loop.
Like an I.
Yeah.
Yeah, and then we need to loop through, so I should start at 0, stop somewhere, right? Where should I stop?
The size of W.
Size of W, yeah. Yeah, we want to look at the first value on W, push that onto V. Like the second one on W, push that onto V. Thanks. And so on. So we have that loop there. So the test code is set up. Let's try it. Looks good. All tests pass. We did it. I think that's enough test code for that. I don't want to overdo it. All right, what's next? Vector insertion? Yeah, that's a hard one. Also 5. Let's do 4 and 5. Not at the same time though. So suppose a vector V contains a sequence of integers ordered from lowest to highest. So it has integers that are organized lowest to highest. V might contain the values 3, 6, 7, and 12. Write a function called insert that takes this vector V as its first argument and an integer k as the second argument. The function inserts k into the vector so that it preserves the order of elements. For example, and here we go, for example, that means we've got test code coming up we can use. Or test case that we can turn into test code. For example, if V were 3, 6, 7, and 12, and K were 5, then after calling the insert function, V would be 3, 5, 6, 7, and 12. There is an insert function in the vector class, but I don't want you to use that. I want you to implement that. All right. 3, 6, 7, and 12. Let's go ahead and 3, 6, 7, and 12. There's the test case right there. And then we're going to call insert into A the value 5. Is that right? 3, 6, 7, and 12. Insert 5. And then when we're done, I guess we could have the size test as well. So the size is 4. Then we do the insert. And then the size should go to 5. The first element is a 3. The second element is a 5. And then 6. And then 7. And 12. Let's get a stub here. So this is an integer k. I think that's the way I had it. So insert k into V. We're calling a vector A here. So which assertion is going to fail? Because we're doing nothing in the function, right? So which assertion, does this assertion fail?
No.
Does that assertion fail?
Yeah, double plus.
That one fails, so we won't even get to any of these down here. Up. Use of undeclared identifier B.
Oh, the one on 12 is still B instead of A.
First group.
Oh, there. Yeah, thank you. A size, A dot size is 5, so we got it. We're in control. All right, let's do the insert now. I'm just going to show you how to do this. Kind of a trick. And it's not just for this problem, but for any problem where you're inserting or adding something and then reorganizing. So on V, let's push back K. So now K is, at this point, I just sort of put what does V look like? With the test code that we have, it's going to be 3, 6, 7, 12, and 5. That's what it looks like now. We added, now, when we do that, this test will not pass. This test passes. That test fails. 5 is not in slot 1. Let's watch that. A1 is not 5. Now what we'll do is we're going to keep a record of this value here, the position. We're going to compare it to the value before it. If it's less than the value before it, then we're going to swap. So that's a loop. We're going to have this loop. And we're going to do this comparison if, and let's suppose the position of K is where? Oh, we got to keep track of the, I'll call it the K position. The K position is going to be, let's see, 0, 1, 2, 3, 4. It's going to be 4, right? That's the starting position. This is position 0, 1, 2, 3, 4. It's in position 4. But that only works when the incoming vector is of size 4. We want this to work with all different size vectors, so we'll need to use v dot size minus 1. So the last position is, the index value is 1 less than the size of the vector. So if the thing at position K position, if the value at K position is less than the value at K position minus 1, then I want to swap V of K position with V of K position minus 1. And I put it in there as a function call. Actually, that function exists, but we should probably implement it. How do you swap the state of two variables? Let me show you how to do a swap. We're going to swap the value at, so once we, if this is true, and it's true for the test code, see, V of K position is 5, v of k position minus 1 is 12. So 5 is less than 12, and so we will swap. So when we do the swap, after the swap, the vector will look like this: 3, 6, 7, 5, and 12. Right? Because 5 and 12 just got swapped. And we're going to keep swapping. We're going to keep swapping until 5 is in a good position. So the next swap, 5 and 7 will be exchanged. And then in the next, we're going to swap again because 5 is less than 6. And then we're done here. Oops, sorry about that. And we're done at that point. We don't want to swap 5 and 3. So that's the purpose of this loop. The loop is to take that value k that's coming in and swap it with the value, add it onto the end through pushback, swap it with the value preceding it until it's in the right spot, and then stop. Now, this is not good for a for loop. It's good for a while loop. It's an example where it's good to have a while loop here. Actually, a for loop is all right too. You could do it with a for loop. I'll just make it an infinite loop. So for now, I'm going to make it an infinite loop. Now let's look at how do we do a swap? I'm going to declare a temporary variable temp, set it equal to v of k position. And then v of k position will get v of k position minus 1. And then v of k position minus 1 gets the temp variable. That's how you do a swap. If you want to swap, see, you want to swap these values here. So if you write the 5 over the 12, then you've got 5, 5. You've lost the 12. That's why you need a temporary variable to hold the value that you're overwriting. Oh, I'm sorry. I'm putting the 12. I'm going 12, 12. I'm going like that. I could have done it that. Let me do it that way. Let's put k position minus 1 in the temporary variable. That's the 12. And then let's write the 5 over the 12. And then put 12 into the position that 5 used to be in. There's a swap. So a swap requires this temporary variable. Now, if the value at k position is less than k position minus 1, also after we do this swap, we want to decrement k position because we move k to an earlier space in the vector. So here k position is initially a 4, and then we move it to position 3. So we have to decrement k position to now equal 3 instead of 4. after we moved 5, after we moved k. And let's suppose, what happens if the value at k position is less than, is bigger than or equal to the value before it? That means k is in the right spot. So what do we do there? We can break from the loop. We're done. So that break statement, that means exit the loop. Does it look done?
Let's throw some negative numbers in there.
Yeah, we got to try to break it. We're not done. All right. Let's try some negative numbers, and also let's try a boundary case. What happens if the value that we're putting on the end of the vector is less than everything? So let's push on let's do this. We'll keep the same A, but we're going to insert -10. So it's going to go past the front, right? It should occupy the first position. A should be of size what? 6. And these are all wrong. A of 0 should be -10. And this is 1, 2, 3, up. 1, 2, 3, 4, 5. So 3, 5, 6, 7, 12 goes to -10, 3, 5, 6, 7, and 12. How's that? That's going to stress it a little bit, isn't it? We're passing in a number that should go into the first position. That's a boundary case. What we tested was the value went into somewhere in the middle. That's the normal case. Another boundary case is where we add it to the end of the vector. Let's do that as well. Let's insert 100. This is the other boundary case. The size is now 7. And the last value will be 100. Oops. Did something wrong there.
6.
What did I do?
It's going to be 6, not 5. You just skipped 12, which
I
technically you don't
just-
need to insert that line.
I just killed it. Yeah. So this should be 12. Did I get it? Does that look all right? Size is 7. So there's 2 boundary cases to check. All right. We've seen the code. We know it passes to here, doesn't it? All right. And then we call it this function here. Is that assertion going to fail? Well, we don't know. Is that assertion going to fail? We don't know. Here's another one. When we call insert, does the program even return? Maybe it crashes with a segmentation fault. Look at the algorithm. Look. I mean, when is it the case we're going to be swapping here, right? We're going to keep decrementing k position. until we find something that's less than or equal to minus 10. We're going to be writing through memory here. We're going to be writing outside a vector. So we're going to get a segmentation fault. Or something. Something crazy is going to happen here. No,
Crazy.
what the heck? All tests passed?
Wasn't expecting that.
How could that happen?
It was a surprise.
How can that happen? I don't believe it. Why does it say recording here? How did that happen? So this passed.
We wrote a really good test code.
Let's see. We hit here, right?
Yeah.
So this test passes right there. That swaps, and then it stops.
Because like the first time,
All right.
we already got it in the right order, right?
We got to break this thing. Really.
Break it.
It has to be broken.
Yeah!
We broke it. Thank God it's broken.
Wait, which one failed though?
Oh, yeah. Which one failed? A of 0 minus 999.
41. Okay, so the first one.
So it wrote it somewhere in memory. At some point, this break was called. And we got out. So we corrupted memory, but it didn't interfere with the functioning of the program. All right, this is what we need to do is we need to, once we put the K into the first position, we need to detect that and then exit the loop. So while K position
Is greater than 0?
exactly, except the condition. If K position becomes 0, which it does, then we no longer, that means K is in position 0.
Wait, so are you saying it failed because it tried to put it in position before position 0?
Yeah, and it did put it there.
Oh, because there's like theoretically a position -1, and then it just stuck 90.
Exactly,
99.
right. It's going to run
Negative.
through negative positions. It's writing into memory.
Huh.
Memory that's not part of the vector.
Wait, so when did it get out of the loop? How did it get to
We don't know. It hit a number that was less than minus 9999.
So it ran at like negative
Yeah,
100 down.
I thought maybe it was going to. Well, let's do it like this. Oops. Oh my God. What did I do? Oh, it's back to true, right?
Yeah.
Okay. Let's do this. Let's, instead of this value, let's pass in max int. Maybe it's max negative int. What is the negative maximum integer?
Possible outputs, maximum value. Is it
Possible output thing on the bottom?
small box below?
Oh, this right here?
No,
Below
down,
that.
down.
It has an actual value in the box below it.
Oh, here.
Is
Like that.
1, 2, 3,
You know, we can just use that. I was going to use that expression, but yeah, let's use the number, right? Oops. Let's use that number.
214 million, or?
Why am I recording? All right, that's the number, right?
2 billion.
It's too dangerous. Nearest the maximum negative value. See, I think we should get a segmentation fault. That's what I'm hoping for here. Well, anyway, it still works that way. I'm not going to go any farther. That's enough. Let's fix the problem.
What does the segmentation error look like?
I'll show you.
Just says segmentation error.
Let me show you what it looks like. All right, that doesn't exist. We're indexing out of memory.
Oh, yeah. He said semicolon versus colon.
What?
V. Is it V
Oh,
dot?
it's A. I finally got that to compile.
Yeah.
That's what it looks like.
Segmentation
We've regained control. Yeah.
So I don't know if this is maybe something we should write a test code for, just a given in this problem, but what if the original vector isn't in order?
That would be, that's a good question. We can have a, we can check that in the end, if, it depends on the problem statement. You know, if the client says, don't check for invalid input. So you say, well, I'm just going to assume that your vector is an ordered sequence of values. And if it's not, well, you're going to get a random result. Or the other possibility is, oh, you're my client and you're telling me that you might pass in an invalid value? Well, I'll have to check to see that it's valid. So we'd have to first check to see that all the values are in order and then crash, you know, or report an error message if that were not the case. We're almost done. Hold on. Let's fix this. That's a very good question, and it's too much to talk about, I guess, right now. So while k position is greater than 0, do the loop. It's got to say all tests passed. It does. All right, we're done. So,